Today's lesson is on geometric sequences. Take a moment, pause the video, and see if you can recognize the pattern in each of these sequences. Good luck. Notice in the sequence above, it looks like it's decreasing, and if you think about maybe if it's arithmetic, looks like the first case it decreases by 3, then it decreases by 6, and then it decreases by 12, and so forth. So it can't be arithmetic, because remember the differences have to be the same, although there's a pattern there. So the sequence is still, looks like it's decreasing, and it's decreasing bigger and bigger and bigger. So it might be another operation to think of. In fact, if you look at the first two terms, -3 and -6, to get from -3 to -6, you could also multiply by 2. In fact, if I take -6 multiplied by 2, that's -12. -12 multiplied by 2 is -24, and so forth. So, looks like the pattern here is multiplying by 2. In this one, notice, again, looks like it's multiplying by something, because it's kind of staggering a little bit, but to get from 10 to 30, you'd have to multiply by 3, but since it's -30, we'd have to multiply by -3 here. And so if you take -3 multiplied by -30, that's +9. And then the last one, if you were to multiply by -3, you do get that -270. So again, multiplying by -3. In fact, anytime you see that alternating signs there, positive to negative, it should be multiplying by a negative number here. But in both cases, you're multiplying, which leads us to what a geometric sequence is. So remember, an arithmetic sequence is adding or subtracting by the same value. A geometric sequence is defined by multiplying or dividing by the same number. We call this the common ratio instead of the common difference, and we use the letter R instead of D. So, take a moment and see if you can determine whether these sequences are geometric. If it is, recognize the common ratio. And then, if it's not, we can just simply say no. So you can pause the video, try the best you can. Good luck. So in the first one, it looks to be increasing, so one might think multiplying. In fact, if you multiplied by 4, we get 20. If you multiply 20 by 4, it's 80. And if you multiply 80 by 4, that is 320. So this would be yes, this is geometric, and the common ratio here, we'd say, would be 4. If we look at the next one, it looks like you're maybe multiplying by 2 or subtracting 7. And so if we look at the next case, if I were to multiply this -14 by 2, that should be actually -28, and it's not. So we know it's not multiplying. In fact, if you notice, these are subtracting by 7 each time. That would be considered arithmetic, and we can say the common difference is -7, but it's not geometric there. If we take a look at the third one, it looks like to be decreasing, so one might think dividing. However, it looks like the first case you're subtracting by 7, the next case you're subtracting by 9, and then you're subtracting by 9 again. And so there is no real pattern here. This would be neither. And the last one, to get from -240 to +120, it looks like the numbers are getting smaller as we go, so it might be dividing by. In fact, if you were to take -240 and divide it by 2, that would be, well, specifically -2, because we want it to be positive and cancel each other out. That would be +120. And so the pattern here is dividing by -2 each time. So this would be considered geometric. However, our ratio is not -2 because you're dividing by -2. Anytime you're dividing, our ratio is represented as a fraction, and so we'd be considered multiplying by -1/2 there. And so if you see that division part, see if way you can represent it as a multiplication instead. So there is an explicit formula, as with arithmetic sequences, that we use for geometric sequences as well. In fact, the explicit formula, we'll call it a sub n, is the first term multiplied by the ratio raised to the n minus 1 power. Now, if you remember the arithmetic sequence that we've already covered before in the previous lesson, that formula was a sub 1 plus n minus 1 times the common difference. And so if you look at some commonality with both of these formulas, both formulas need the first term and whatever that pattern is. So notice a sub 1 and whatever that pattern is, common difference. And remember when we wrote the formula, we kept that n minus 1 in the mix. In fact, you're going to do the same here. That n minus 1 is going to stay as an exponent because the n represents whatever nth term we're finding. Okay, and the a sub 1 still represents first term. And then that little r is now that common ratio. So what you're multiplying or dividing by. So let's get practicing some writing formulas here. So here's our first example. It says write the explicit formula for the geometric sequence below. So it is telling you that it's geometric, so we should be able to recognize that. So if we look at the pattern here, it looks like it's increasing, so it's got to be multiplying by something. In fact, to get from -2 to -4, I'd have to multiply by -2. And so it looks like you're multiplying by -2 every time. And so our common ratio would be -2. The first term's given as -2. And so if I write out my formula for the geometric sequence, remember that n minus 1 stays, and so the only thing we'll sub in is the first term and the ratio. So the final formula would be -2, and then we'd have parentheses around the ratio, which is also -2, and then it's raised to the n minus 1 power. And so this would be the explicit formula for that geometric sequence above. So let's take a look at another one. Here it says, looks like it's decreasing, and so remember it's geometric, so it can't be subtracting, so I believe it would be dividing by something here every time. And so to get from 81 to 27, an easy way to remember that is if you take that first term and divide by that next term over, that's going to tell you what it's dividing by each time. But remember when you're dividing, the ratio is not 3 here because that's what would be multiplying. So the ratio we'd say would be 1/3. That's the same as dividing by 3. Multiplying by 1/3 is the same. And so the ratio is 1/3. The first term is 81. And so if I write my formula out for explicit formula for geometric sequence, sub in the known values, first term's 81, common ratio is 1/3, and then remember that n minus 1 stays in our formula because we need a variable. So I want you to take a moment, pause the video, and see if you can write the explicit formula for this sequence below. Good luck. So it looks like the numbers are getting bigger and bigger here, and so it seems like it'd be multiplying by something. And notice that the signs change. So it's probably multiplying by some negative number. In fact, you might have recognized it's multiplying by -3. Right? 1 times -3 is -3. -3 times -3 would be +9. +9 times -3 would be -27. So the ratio here is -3, and the first term is 1. I always get a habit of writing out the formula first and then subbing in what I know. So it'd be 1, and then in parentheses, -3 to the n minus 1 power. And that would be our formula. So there is a recursive formula we can use to represent the sequences. In fact, recursive formula, remember, you always state the first term, so whatever that is, and then there is a line before it that represents the previous term. Well, if you're multiplying or dividing every time from the previous term, then remember that previous term notation would be a sub n minus 1, and we'd put multiplied by whatever that ratio is. So this would be the recursive formula for a geometric sequence. So let's take a look at writing it now for a given sequence. So you still have to recognize those key parts. We still have to recognize the first term, so let's write that down. But now it's going to be written as a line. So a sub 1 equals -1. And then to find the next term, because remember you need two parts for the recursive formula, it looks like it is multiplying by -2 each time. So if I were to write that as an equation, you're taking the previous term, remember this represents the previous term, and we're multiplying by -2. And so overall, both those lines would be considered the recursive formula. So see if you can try to write the recursive formula of this geometric sequence. Good luck. So it is decreasing here. Some of you might recognize that it's dividing by 2 every time. And so if you're dividing by 2, remember the ratio is not 2, it's 1/2 then, because you have to think about how to multiply to get the same value. So the ratio is 1/2. The first term is 64. If I were to write my recursive formula, remember first is identifying the first term, so that's 64. And then the next line would be your formula part, which you're taking the previous term and you're multiplying by 1/2. And so together, this would be the recursive formula for that sequence. So now it's your chance to practice some of these. So there's the practice online Canvas attached with the key. So work as many as you can out. Try the best you can on these. Make sure you're checking the key as you go. And don't forget to submit that formative assessment before the end of the day. Have a great rest of your day.